I'm walking out. Watson's waiting on me. So.
Alright, timer is not working, so I'm going to have to put my phone up here for you. Ready? 21 through 25. Ready? Should have had your stuff out already like I asked you. Go. 21 through 25. 21 through 25.
Good morning, everybody. I hope you're having a great day today. We have a few announcements today, and first, here's an announcement from HOSA.
Good morning, guys. I just want to remind you all that Thompson will be hosting a dodgeball tournament. You can sign up in Coach Garrett's room 207. Each team will be made up of 5 players and 1 coach, and the cost is $20 to enter per team. The tickets will go on sale the week of the tournament. Remember to sign up and get your costumes and stuff together. Yeah, that's it. Have a good day.
And now here's an announcement from First Priority.
Hey guys, this is Jeremiah from First Priority, and I wanted to invite you all to First Priority tomorrow morning at 7:45 in Miss Sophia's room. That's in the 400 building, by the way. We would love to see you come and just have a great time.
We'd like to congratulate a number of our students this morning. The JV boys soccer team won Friday 4-1 against Calera, so congratulations to them. And our majorettes and warriorettes competed at the National Baton Twirling Association State Twirling Championships here at Thompson this weekend. The majorettes placed first in the high school majorette division and the high school halftime division. Emma Blazing placed first in the senior solo show twirl division, and the warriorettes placed first in the high school dance and high school pom division. We'd like to congratulate the girls tennis team who placed second in the Shelby County tournament on Friday. Nicole Nowak brought home the number one seed singles first place. Nicole Nowak and Natavi Machego won the number 1 seed doubles first place. Lindsay Musso and Tiffany Milan placed second in the number 3 seed doubles. The next home match is tomorrow against Huffman at 3:30, and we'd love for everybody to come out and support the tennis team. Our boys tennis team also won over Gulf Shores this weekend. The doubles winners were Daniel McCammon, Asa Render, Jaden Sims, and Emerson Price. Singles winners were Daniel McCammon, Asa Render, Jaden Sims, and Emerson Price. So congratulations to our tennis team. The THS Future Teachers of Alabama chapter here at Thompson participated in the state conference last week. Our chapter won the Outstanding Campus Project Award for our Remembrance Day Poppy Project. Jada Washington was elected president of the state chapter. Danielle Cook, Lily Champagne, and Nathan Renew were elected to the FTA State Board. Congratulations to our students for representing us so well. In celebration of Pi Day on Tuesday, March 14th, FTA will be having a bake sale in the gym lobby during the zero period. All items are $1 and will include an interesting fact about Pi. Proceeds will be used for chapter projects. Please support our FTA chapter and learn more about the wonders of Pi. This week is
So we are a little bit behind, so I need you to go ahead and grab your notes quickly, and let's go ahead and get started on some stuff.
Sorry for the interruption. I have one more announcement, and this is for senior students. If you still have proofs out from your senior portraits, or if you owe Belmont Studios for pictures that have been taken, please come by the office and either bring your proofs or come by and look at the list, and we will gladly show you what you owe Belmont. We have quite a few seniors who still owe Belmont, and they send us a list of those seniors who either, one, you owe them for services rendered, pictures taken, or you still have proofs that need to be turned back in. So please take care of that as soon as possible. Thank you, and have a great day.
Okay, here we go. So let's look at number 1. So you cannot have a square root on the bottom, okay? So what's the opposite of division that you're doing? Multiplication. There you go. So we're on that very first page from Thursday. And you're going to multiply by what you're trying to fix. What am I trying to fix?
The
the square root of 6. And if you do something to the top, what else do you have to do? You got to do it to the bottom. There you go. All right, can I actually multiply 2 and 6 to give me 12? What? Yes? Why? Very first page we got on Thursday. Only page that we've worked on so far. Why can you multiply 2 and 6? You can. Why can you, though? Do what? I can't hear you. Come on, guys. Wake up. Why can I multiply 2 and 6? Because they both have square roots. Very good. All right, so what's 2 times 6, Kai? 12. Square root of 12, right? Thank you, sir. All right, Peyton, on the bottom, can I multiply 6 and 6? Huh? Yes? Why? Because they both have square roots. Very good. So, Hunter, what's 6 times 6?
36.
36. Very good. Reagan, do you see anything that I can do? All right, square root of 36 is 6. Very good. Okay, so think back to what we did last week. Do you remember all those perfect squares and perfect cubes and perfect fourths and things like that we did? All right, so give me some perfect squares. What's my first perfect square? 1. What's the next one? And the next one?
15.
One more.
25.
Okay, let's look at this. Is 12 on that list? No. But is there one on the list that goes into 12? 4 times what? 4 times 3. Very good. All right, Kyron, what's the square root of 4? 2. So 2, and then the 3 stays inside. All right, Sydney, can I reduce this 2 and this 6? Huh? Yeah? Will, could I reduce the 3 and the 6? No, why? There you go, perfect. All right, so Tyler Emerson, when I do 2 and 6, what number goes into both of them? 2. Very good. So 2 divided by 2 is 1. 6 divided by 2 is 3. So, Kyron, can I cancel out these 3's? Nope. Leslie, why can I not cancel out the 3's?
Because the bottom one doesn't have a square root.
Perfect. Perfect, perfect. Okay, let's go number 2. So, what's wrong with number 2? What do I have to fix?
It's 1 and
Okay, I got an exponent first of all. Like, why am I going to rationalize the denominator, though? What's wrong with the denominator? They're all under the square root, right, Jacob? So I can say square root of n to the third and square root of 8. Do y'all see the difference now? All right, so what am I going to multiply by? What's my problem? Square root of 8. And if I do it to the top, I got to do it to the bottom. There you go. All right, so on the top, I can't actually multiply those, but can I smush them together and make it one big radical? Yes, because they both have a square root. Very good. So it'll be 8 n to the third over how much, Jonathan? What's the bottom give me? 8 times 8, baby. Well, go get one. 64. Very good. Go get a calculator. All right, Salma, what do you see that I can do here? All right, what's the square root of 64? 8. Very good. Very good. Okay, let's see. Can I break up, do you see that I can break up these two somehow? No, you don't see a number that divides into 8 on that list? 4. 4 times what? 2. There you go. Okay, we got to remember how to do the letters. You ready? So I'm going to take 3 and divide it by what number? What kind of root do you have? What kind of root do you have right here? Square, what square mean? 2. So what am I going to divide 3 by? 2. Does that go evenly? No. Okay, so what number underneath 3 divides into 2? 2. But then you still have to have 3 of them, so how many more do I need right here? 1. There you go. Just bringing back some memories from last week. Alright, what can I do? Can I take the square root of 4? Yeah, what you get? 2. Can I take the square root of 2? No. So you leave it inside. Can I take the square root of n to the second? Come on, we just talked about how to do this. How do we do that? You divide it by 2. You take half of it. What you get? Just an n. And can I do anything to this one? Nope. You leave it inside over 8. Alright, Allie, which ones can I reduce? 2 and 8. What number do they reduce by? 2. So 2 divided by 2 is 1n. Square root of 2n. 8 divided by 2 is 4. Are y'all okay? Alright, let's do one more. Let's do number 3. Okay. Jacob, what do you notice? They're both underneath the square root, right? So I can break it up. Alright, Sydney, what would I multiply by? There you go, square root of t to the 4th. Not square root of t, square root of t to the 4th. Alright, so smush these two together. This would be 32 square root of, 32 t to the 4th. Alright, Kai, when I multiply those t's, do you remember what I do to the 4's? You add them, Kai, very good. So 4 plus 4 would be 8. Alright, Leslie, do you see one of those numbers at the top that'll divide into 32? $16 times what number? 2. Very good, very good. Alright, Hunter, can I take the square root of t to the 4? Can I divide that by 2?
Yes.
Yep, so we're just going to leave it alone, right? Alright, Allie, how do I take the square root of t to the 8th?
You divide it by 2.
And you get?
T to the 4.
Perfect. Alright, Reagan, here we go. Do you see something in here that I can take the square root of?
16.
What's the square root of 16? 4. Very good. Alright, Jonathan, do you see something else in here I can take the square root of?
To the 4th.
Alright, what you get?
2.
To the 2. Very good. And then Tyler Mims, what's left inside? So one thing I didn't mark out. 2. Alright, Peyton, do you see anything I can reduce? The 4? There's nothing to reduce it with.
Oh, I don't know.
Tyler, can you help her out?
The T2, the 2.
Alright, Peyton, so why can I reduce these 2?
Because they're the same.
They're the same, right? They don't have square root? Okay.
On the 2, but the first 2.
Oh, okay. Alright, so when I divide the bases, what do I do to the exponents?
Right.
You subtract them. So don't do 2 minus 4. Do 4 minus 2. What's 4 minus 2?
2.
And where's that leftover t to the 2 go?
On the bottom.
On the bottom. Very good. And then square root of 2. Y'all okay? We're going to do one more? Okay. Alright, here we go. What is different about number 4? It has a 4th root. Okay, so it's still the same thing. So, Jacob, how do I break these up? Same thing we did on the other 2. What do I write?
6.
6?
That's some with square root.
Not a square root. What is it?
Yeah,
It's a 4th root. It's how we've said that every day. 4th root. Alright, what goes on the bottom?
5x 14.
5x with a fourth root. Very good. Y'all okay so far? Okay, what's my problem? What's wrong with this? Would help if you were off your phone, because I would hate to take it up on a Monday.
That's a 4.
It's got a 4, yeah. What's wrong with it? It's got the square root in the bottom. Thank you. Not a square root with a fourth root. All right, so what do I multiply by? Fourth root of 5x. Yeah. And if you do it to the top, you got to do it to the bottom. All right. Kyron, bless you. Kyron, can I multiply 6 times 5x? Leslie, can I multiply 6 times 5x? I can combine them. What's it give me?
Fourth root of 6 times 5.
Which is? What's 6 times 5? Use your calculator. 30x. Very good. Very good. All right, Karen, one more time. Can I multiply the bottom ones? Yes, I can multiply anything, right? Okay, so what's that give me when I multiply those?
25.
Fourth root of 25, what? X squared. Very good. There's 2 of them. X times x is x squared. Well, let's remember fourth roots. What's my first fourth? 1. What's my next fourth? What's 2 to the 4th? Use your calculator. What's 2 to the 4th? How much? 16. Very good. What's the next one? What's 3 to the 4th? 81. Let's do one more. What's the next one? 4 to the 4th. 256. Okay, so is 25 on that list? Get off your phones. No, it's not, right? Okay, so have we fixed the problem? Have we fixed the square root or the fourth root on the bottom? So what do we got to do? Multiply by what? You're right. We got to multiply by something. What do we multiply by?
56.
Come on, guys. It's the same thing we're doing again. What do we got to do? Multiply by what? The fourth root of 25. Actually, you just got to do it again, okay? Let's do it again. Let me rewrite this. Alright, so if you do it to the top, you got to do it to the bottom, right? We just got to do this one twice because it has a fourth root. Alright, Mike, can I multiply 30 and 25?
No.
Yeah. What do you get when you multiply 30 and 25? $750. Okay. All right, Blake. What's x times x squared?
X cubed.
X cubed. Very good. All right, Hunter. What's 25 times 25?
625.
625. Okay. And Allie, what's x squared times x squared? X to the 4th. Very good. Okay, did we go that big yet? 625, is that on my list? No, let's do it again. Let's see, this is 1, 2, 3, 4. What's 5 to the 4th? What's that one?
625.
Ooh, looky there, 625. So, can I take the 4th root of 625?
Yes.
What's it give you? Gives you how much? Remember how to do it? Hit 4. Hit math. Go down to number 5. And then type in 625. What do you get? You get 5. Very good. All right, how do I take the 4th root of x to the 4th? What do I divide 4 by? 4. What's 4 divided by 4? 1. Very good. Did I get the root out of the bottom? Yeah. All right, here we go. Let's look at the bottom. Bottom ones, you're going to work on 1 and 3. Mark out number 2. Y'all are going to work on 1 and 3. Okay, so try those real quick. 1 and 3. All right, y'all get that so far on number 1? Okay. All right, keep going. So you can keep going on number 1. When you finish number 1, go to number 3. Very good. All right, so this is what Jacob just told us. The 8 of the ninth can be broken up as 8 and 1 because 8 divides by 2, right? And then 5 can be broken up as 4 and 1. And the square root of b to the 10th is 5. How to get the square root of b to the 10th is 5? What do I do with 10? Divided by 2 because this is a square. Square means 2. 10 divided by 2 is 5. All right, keep going. You can break that down a little bit more. Keep going. All right, did y'all take them out like that? You're just dividing them by 2. 8 divided by 2 is 4. 4 divided by 2 is 2. Okay, do you see something else you can do?
No.
You should.
Oh, wait.
Again, look at the 4 that we did with the letters.
You're not about to do it again.
Huh?
Can you do it again?
No. What can you do to reduce? Thank you. These two. Do 5 from 2. Do it so it's positive. What's 5 minus 2? 3. Where's the leftovers go? On the bottom. Are these two like?
No.
No. So now you're finished. All right, number 3. Try number 3. All right, did y'all multiply by 8?
Yes.
All right, what's 5 times 8? What's 8 times 8?
64.
All right, which one can I take the square root of? 64 gives you how much? 8. All right, what perfect square divides into 40?
4.
4 times what number is, there you go, 10x. Not x times x, there's only one x. You cannot change that to be anything but 1x. All right, what's one can I take the square root of?
4.
What's the square root of 4?
4.
2. And then leave the other one alone. And then these two reduce. What do they reduce by? What number? 2. What's 2 divided by 2? 1. What's 8 divided by 2? 4. Do the 4 and 10 reduce? No.
This is going so fast, I don't know what's happening.
Square root of 4 is 2. 2 and 8 reduced by 2. 2 divided by 2 is 1. 8 divided by 2 is 4.
Okay.
Got it?
Ms. Blackman, I
Yes,
have a question.
Yes, sir.
Okay, so whenever you do the whole divide by 2 thing with
Yeah.
the 4 times 10
Yeah.
x step, why wouldn't you divide the 10 as well? Because it's divisible by 2.
2's not on that list of perfect squares. 4 is.
Or,
That's-
so you're not dividing everything by 2.
No, you're figuring out what perfect square. First of all, you're thinking if 40 is a perfect square, and it's not because it jumps from 36 to 49. So then you ask yourself what perfect square divides into 40, and it's 4 times 10 is still 40. And then this one, the reason you did that is because now this is a perfect square. You can take it out as 2.
Okay, yeah, I thought you were dividing by 2.
No. Well, that would have given me 20 anyway.
Yeah.
Oh, you're talking about the 4 divided by 2?
Yeah.
No, that's just a coincidence.
Okay,
Yeah.
cool.
Because if this would have been 16 instead of 4, square root of 16 is 4. Half that would have been 8. So,
I'm
so
just making sure, 'cause I was like, nah, I'm confused.
all right, flip over on the back of that. Here we go. We gotta keep going, okay? I'm sorry, we're a little behind. We gotta keep going. There's a back. No, it's not homework. We just gotta start doing it. Okay, here we go. Let's look at the very first one. All right, so real quick, here we go. List those perfect squares. What's the first one? Come on, let's go.
4.
1,
1, 4.
4, 9.
16.
Yep.
25.
Yep.
36.
Yep.
49.
Keep going.
64.
Yeah.
81.
Yep.
100.
All right, let's stop right there. Here we go. What number am I dealing with first? So pretend like that's not there. Which one am I dealing with first? The 4 or the 8?
4. So it's a square root. Or is
That
it-
has a square root on the 4?
Nope, you're dealing with the 8.
You're dealing with the 8. All right, 8. Here we go. Is 8 on that list? No. Is there a perfect square on that list that divides into 8?
Yeah.
What? 4. So bring this 4 down. All right, 8 was what times what?
8 times.
No.
4 times
4 times 2 is 8. Very good. All right, let's look at the second one. Which number am I dealing with on the second one?
3.
No.
He squared it.
50. This 50. Why the 50? Because 50 has the what? All right, bring your 3 down. Is 50 on that list? No. 25 goes into it. 25 times what?
2.
Times 2. There you go. Y'all okay so far?
Yep.
All right, here we go. Bring your 4 down. Don't do anything to it. He does not have a square root. Just bring him down. Okay, look at this 4. This one has the square root. What's the square root of this 4? 2. So what am I going to do to that 4 and this 2 when I bring it out? Add, subtract, multiply, or divide? Multiply. Very good. All right, and what number stays inside? The 2. Bring down your plus 3. All right, what's the square root of 25?
5.
What am I going to do to the 3 and the 5? Multiply. What number stays inside?
2.
2. What do you see that I can do now?
You can take out the 2 twos.
Not yet. Not yet.
You can
Order of
multiply,
operations. Multiply first. Multiply first.
and then you can add those when you multiply.
Uh-huh. Hold on a minute. Let's see. 4 times 2 is 8. 3 times 5 is 15. All right, now, Blake, why is it legal for me to add the 8 and the 15 now?
Is that like
Why are they like terms?
because
What makes them like?
they're not.
They both have a square root of 2. Very good. All right, so what's 8 plus 15? 23, and then do not touch the 2's. Just leave it square root of 2. Are y'all okay? Okay.
You don't.
That's pretty
No, remember if you did x plus x, it's still just 2x.
That's the truth.
All right, let's do number 2. Here we go. Grab your calculators. Let's see if we can get through 2 and 3 before the bell rings. All right, 98. Is 98 on that list? No. Is there one on that list that divides into 98?
49.
49 times what?
2.
Times 2. Bless you. Very good, Tyler.
Good job.
All right, bring down your minus 2. What about 32? Why am I dealing with 32? What's the 32 got?
It's got a square.
It's got a square root. All right, 32 is not on that list.
16 times.
16 times 2. There you go.
This one's easier than the other one.
You think so?
Yes.
All right, which one? What am I dealing with here? What's the square root of 49?
It's
7. And what stays inside?
The 2.
2. All right, all you're going to do, don't touch that 2. You're just going to bring it straight down. All right, which one am I dealing with?
16.
What's the square root of 16? 4. All right, what am I going to do to the 2 and the 4? Multiply. And then what stays inside? The 2. What do you see first? All right, what's 2 times 4?
8.
8, and you just bring that minus sign down. All right, are they like?
Yes.
Why? Because they both have square roots of 2. There you go. So what's 7 minus 8?
-1.
Minus 1. Very good. Very good. All right, let's see if we can do this last one.
Here.
All right, here we go. One at a time. Okay, guys, one at a time. Very first one we're dealing with is 5 square root of 12. Which one? 12. All right, 12 on that list?
Nope.
Nope. Which one goes into it?
4.
4. 4 goes into it. 6 not on that list.
3 times.
4 times 3. There you go. 6 goes into 12, but I don't want 6 because 6 is not on that list. All right, what's the next one we're dealing with?
Bring on the plus 2.
Bring down the plus 2, and what's the one we're dealing with?
There's 27.
27. All right, 27 is not on the list, but which one goes into 27?
9.
9 times what?
3.
3. All right, what's the last one we're dealing with?
128.
128's not on the list.
64.
64 times, bless you, times what?
2.
Times 2. There you go. Are y'all okay so far? Okay, here we go. Which one?
4.
4. What's the square root of 4?
2.
So it's 5 times 2, square root of 3. All right, bring down your plus 2. Which one are you dealing with? What's square root of 9?
3.
So times 2 on the front. All right, minus, which one are you dealing with?
64.
What's the square root of 64?
8.
8. There you go. All right, multiply first. What do you see you can multiply? 5 times 2 is? 10 square root of 3. 2 times 3 is? 6 square root of 3 minus 8 square root of 2. Which, get off your phones, which ones are like? The square roots of 3. These two right here, okay? Not the 8. So it'd be 16 square root of 3.
Minus 8 square root of 2.
Perfect. Do not touch the 16 and 8 because they are not like. One has a square root of 3, or one has a square root of 2. All right, tomorrow we are going to finish up this lesson, and then all we're going to do for the next day is checkpoints. We've got 2 checkpoints. And then I am trying my best to have a test on Friday so we can get caught up with everybody. It does? Okay. Some of it's a little confusing, but...
Dude.